I'm sure everyone can relate to that sinking feeling in the pit of your stomach when you wake up some mornings and you just know you're going to break a tap. Well, this is one of those mornings. Longtime viewers might know that my preferred method to break them is with a tap wrench, manually, the old-fashioned way. But if you really want to go through some taps, you'll need one of these, a tapping head. With a head like this, you can let the machine do the work of breaking taps for you. Before these end up spending the next 2 years of their lives being pushed from one end of my shop to the other, I'd like to finish these tool holders and quickly revisit the DRO tool offset thing. Each one of these have 5 holes that need tapping, and they're relatively deep, in tough material no less. Now, I started in on one of them, only got about 4 threads deep before I realized I didn't want to do all of this by hand. Think of that just a minute. 5 3/8" holes per holder times 4 holders, that's like the equivalent of tapping one giant 7.5" hole by hand. Questionably. For the metric crowd, that's like one big 190.5 millimeter hole, which is why I'm keen on getting this thing here to do it. But plot twist, this tapping head has never been a great fit on my milling machine, in more ways than one. First, more often than not, it's too long. In going from an ISO 30 taper that my mill has, through an adapter to convert it to a Morse taper, through the head, and with a tap installed, well, I have very little to no space left for my parts. In this case, I only really have about an inch left, 25 millimeters. I have made this work in the past. In fact, I made the original tool holders video with the same exact setup, but I shortened the tap and used a slightly lower profile vise. Those sorts of shenanigans are getting a little old, frankly. And the second, more nerve-wracking issue, these tapping heads are easier to use, I believe, in a machine that has a quill, or at least a machine with a bit more control in the Z direction. A quill would be the part that comes down out of the head, like on a drill press. But this machine doesn't have one. It's a fixed head. You may have noticed that to drill holes on this mill, I have to do it by raising the table, bringing the work up into the drill instead of the drill down into the material. I can't move the quill down like a drill press. If possible, I'd like to replace the existing tool shank with something that's ISO 30, so I buy back maybe a couple inches of space. We'll take this apart in a minute and see how it works, see what the parts look like. In the meantime, let's explain why not having a quill makes life a little bit harder for me. When a tap engages the work, either tapping by hand or using a machine, it's going to pull itself in at a very consistent rate, at whatever the thread pitch is that it's cutting. The tap is quite literally screwing its way into the work. When you're done, you stop the machine in this case and reverse the spindle. This is not an automatic reversing head, and the tap would unthread itself while you helped it up by retracting the spindle, taking a little bit of weight off. Since we've already established that I have no quill in my spindle, I've got to do all of that motion using the table under power feed. That means I have to do a little bit of math to get the table to move up at the same exact rate the tap is trying to thread its way into the work. I can of course adjust the feed rate of the machine, how fast it moves, using a little dial super conveniently located way at the back behind the mill and near the floor, in the dark. This is showing millimeters per minute if you can read those numbers. Unlike the spindle speed, the feeds are not continuously variable, so I can only change the feed rate in increments, which may or may not match up with the thread pitch I'm trying to power tap. Think of it like that movie Speed, where the bus has always got to go 16 TPI or it would explode. This is the same thing. If that tap doesn't move at 16 TPI up and down, it's going to explode. And the problem is that the gas pedal on this bus isn't infinitely adjustable, but the tapping head has another trick up its sleeve. The collet, or the drive shaft, has some float in it. It's driven rotationally, but it's spring-loaded in the up and down direction. If the hole isn't too deep that I'm trying to tap, the mismatch in the power feed and my thread pitch could be absorbed by that motion. There's the shank it was built with. That's Morse taper 2, I believe. And to get it to fit my machine, I need to use a Morse taper to ISO 30 adapter. This is what's eating up a ton of my space. Ideally, I could break this down and replace that Morse taper 2 directly with something that's ISO 30. In theory, that gets me all of this space back, or most of it anyway. This isn't the shank I'm going to use. I have 2 of these. They came with my mill. In fact, I've never been able to figure out what these are for. A little bit of a tangent here, but if anybody knows what these things do, they're ISO 30 on the back end, but they have no drive flange. They're also drilled and tapped for some massive bolts. Almost look like shell mill holders or I don't know what. I've always wanted to use these for something, but without this drive flange, this flange that engages the dogs on the spindle face, I'm not sure what the holding power of just an ISO 30 taper is. I don't think it's that much, but one step at a time. Let's see if we can't break this thing down. Slow down, cowboy. Before we break it down, let's just talk about how this thing works. We already saw that the drive end has a little bit of play. It's spring-loaded. It holds taps via a small plastic collet to keep it centered. That's it there. I don't have too many of these. And it has this sort of two-jaw floating clamping mechanism. It's just a hex screw that if I tighten it, brings these two discs in and clamps on the square part of the shank on the taps. In addition, in here, there's a large clutch. The input and the output aren't directly connected. If the tap binds while it's tapping a hole or bottoms out or whatever, the clutch in here allows this portion to slip. So the machine keeps turning and the tap stops. Keeps it from breaking. And you reverse your machine and with any luck, it'll withdraw your tap, leaving you with a tapped hole. This is marked. It has settings from 16 down to 5. This is a metric tapping head. Its capacity is 5 millimeters, which is probably around a number 10 screw, maybe number 12, up to 16, which is pretty big. I don't know why I'm having trouble doing that conversion on the fly now. 12 millimeters would be ½ inch. I don't know, 5/8 maybe. You adjust this clutch because obviously a larger tap is going to want more torque than a smaller tap. And if you set the torque too high on a small tap, well, you run the risk of breaking it. Anyway, I'm pretty sure this unscrews. I barely broke this down when I first got it, and it kind of scared me, so I quickly put it back together. This time we're going all the way. You can just make out the clutch plates. It's chocked full of very foul-smelling grease. I noticed that the first time around. My tendency was to clean that out. I'm not sure if clutches like this should be coated in this sort of thick grease, but it seemed to work, and that's how I got it, so I've left well enough alone. At this point, the head and the tail should slip pretty easy. Let me mark that. The collar is putting no load on this clutch, so this should be the lightest setting. And other than some drag from the grease, I can turn the drive end without turning the driven end. All right, it's got a thing at the back. I had to get some gloves on. This is going to get yucky. I can't immediately identify how this comes apart. All right, looks like there's a screw down in there. Here's the spring that gives the tap driver some compliance. The drive end has 3 splines cut in it that engage in the tabs of the clutch stack. A set of ball bearings down in there that act as keys that appear to ride in these keyways. Those would be what transmit the torque from the business end of the clutch to the tap driver side. What I'd like to replace is this Morse taper piece. That is integral. It's all one thing. That's what integral means. I hit this with a file and it's not hardened, so that's promising. However, it dawned on me that I can't readily replace this with an ISO 30 taper because this whole back stack needs to assemble from this side. That would not fit over an ISO 30 taper. I could make this in 2 parts, I suppose. Save this end. That might be a project for another time. Give me a minute. I'm going to formulate a plan B. I made a new driver. I was just going to cut the taper off when I thought I'd save it. I'll keep this in the box with the kit in case I don't know, ever want to go back. Easy enough part to make at any rate. Just a couple of diameters and 3 slots at 120 degrees. Ended up going with a straight shank. I think I can hold this in a collet chuck and get some space back. Here's the original in the ISO 30 adapter. And this one should fit in ER20, I think. This is the shortest collet chuck I have. So if we compare dry flange to dry flange, about 1 inch. Ideally, I could eliminate this entire collet area and get back, I don't know, another 1.25 inches there. But this should do for now. Let's try to put it together. I should probably go back and watch that video how I took this apart. There might be a little burr in here from the chamfer. Am I out of frame? This, by the way, is the first part I did with the DRO. It hadn't dawned on me till now that the DRO makes working in blind bores like this a heck of a lot easier. You know, I guess once you get to trust it. One of the clutch plates is out of sync. First hole, first try with the new shank. The other tapped hole you see is the one I started by hand and gave up on. Started off well, then this happened. I'll admit when I saw the tap stop, my heart stopped along with it. Then I realized I hadn't set the clutch for this tap size. The tension was too light. Totally my fault not having turned it up to 11 ahead of time. For any cynics out there who dismiss this all as CGI, there you go. Taking a step back, you can see my stack up is still a smidge on the tight side. Had to still use the lower vise, but at least the tool holders fit and I can get through this project. Again, this does require a bit of gymnastics. I start the spindle on forward and engage the table feed. And in this shot, if you look close, you might notice the tap even starting to pull the part up out of the vise. Should have tightened that a bit more. How the tap didn't break, I'll never know. Anyway, without dwelling on the past, I quickly reverse the spindle and simultaneously flip the power feed. This would have all been much easier with a quill, or better yet, an auto-reverse tapping head. Note, I'm using a spiral fluted tap. That means the flutes in the tap are spiral, like a twist drill. As you can see, this sort of tap evacuates the chips out the top of the hole, pushes them out the back. A regular tap would just pack the flutes. You'd need to retract it and clean it out occasionally, which isn't something I want to be doing with this setup. You can also get spiral point taps, also called gun taps. I know it gets confusing. Gun taps have straight flutes, but have sort of a spiral cut on the leading cutting edges. In contrast to spiral flute taps, gun taps or spiral point taps push the chips out the bottom of the hole that they're tapping, instead of the back, instead of out the top. Either would have worked in this case, since it's a through hole with plenty of clearance on the bottom, but my spiral flute tap in this size has a larger shank diameter. Basically, it's beefier, so hopefully helped minimize my chance of breaking it. If you grew up watching the same commercials I did as a kid, you may still be wondering how exactly you spell relief. For the record, it's R-E-L-I-E-F, and that's what I'm cutting here, relief in that lower corner. If this setup looks a bit silly to you, I won't argue, but it's the only tool I had that could reach into that back corner. I'm adding a small undercut, effectively eliminating that internal corner, so I can later come back and grind that surface, the surface where the tools will clamp against in these holders. It's a lot of really hard work grinding an internal 90-degree corner. The standard cop-out is to remove that corner altogether before grinding. I'm set up on the grinder and I'm going to be side-wheeling these parts. Now, cutting with the side of the wheel always gives me the heebie-jeebies. It's like when you're parallel parking and your sidewalls hit the curb. Not that I've ever done that. Ideally here you'd want to use a cupped wheel, which I don't have. So what I'm doing here is relieving the side of a regular wheel, cutting a bit of a concave immediately behind what will be the cutting edge. I only want that first, I don't know, 1/8 of an inch, 3 millimeters of wheel to make contact along the side of the tool holder. If you watch that perimeter during the grinding, that's where you should see, I guess, the sparks flying from. And as it wears and fills up, you'll see that kind of get a little bit darker. The part I relieved should stay clean. Should never come into contact with the work. I'm at the surface plate. I'm checking each one before I take them out of the grinding vise. I've already measured this one. This is the second one, and so far they look to be pretty consistent. Again, I'm measuring the perpendicularity between that bottom surface that I just ground and the dovetails. The dovetails are being held in pins in a grinding vise that I trust. I trust this to be square. Across that distance, I'm maybe 3/4 tenths. The other one was a smidge worse, 5 tenths, maybe half a thou. Could have been a little bit better, but I'm happy with that. This is holder number 3. This hasn't been ground yet. Hopefully you can still make out that mill finish in there. I'm just checking them out ahead of time to see what I'm in for on the grinder. Now, for some reason, these have all been about 5 thou out. 0 there, drops 5 thou. If I 0 that again, it'll pick up 5 thou. That was a little more than I was expecting right off the mill. And they're all relatively consistent that way, so I'm starting to suspect my vise wasn't trammed in, or I don't know, maybe one of my dowel pins are crooked. So somewhere I got sloppy. As they say in France, these parts are finis. I'd like to cold blue these. I'll be sure to show that to you. Not sure why, but everyone seems to get a kick out of that. First, however, these will need a thorough cleaning and degrease. I think I'll let the ultrasonic cleaner do that. Get all the junk and gunk out of the tapped holes here. Before I do that, though, I'm going to go through each one and make sure they're completely deburred. Absolutely no sharp edges on these things. When it comes to chamfers, you don't want to cut corners. All right, here goes nothing. I couldn't really find a container, so I'm using a tool storage bin. I can just get 2 in here. I don't know if you can tell, but they're already starting to change, starting to oxidize. I always get a ton of questions about this stuff. This is selenium dioxide. It's cold blue. I buy whatever is cheapest on eBay. Just go on eBay, type in cold blue or Celine Dion, find the cheapest one. You can get this stuff at like gun shops, sporting goods places, but they'll give you like a half-ounce bottle for 20 bucks or something silly. Now, I've usually done these cold, but I've had a lot of comments in the past suggesting that I preheat them, warm them up before I put them in this solution. I didn't do anything fancy. They just sat in the ultrasonic cleaner at 40 degrees C. That's somewhere around 100 F. I mean, I did wipe them down with acetone, so they probably cooled off a little bit, but they're still warm to the touch. I don't know if I should be messing with these while they're in there, but I always get different results anyway, so what's the point? From what I understand of what this stuff does, it's growing a very thin layer of porous oxide. I'm going to take these out, put the other ones in, and then rinse these off. I'll blow them down so they're dry and then coat them in some kind of thin machine oil. That light oil should permeate into the oxide, and that's what actually provides the protective coating. I mean, it's not perfect. It's not as good as like a hot glue process, but it's better than nothing. Here's what they look like after they've been washed and dried, or more or less dried. It's either sort of all splotchy and weird colors. Once they're oiled, they're still splotchy and weird colors, but they look a lot better. Those need a little bit more cleaning. And when they're oiled, they're not oily. Like the oil is absorbed into that layer. They feel dry to the touch. Maybe you can see what a little bit of oil does to these. These did spend more time in there. They're a little bluer, but I haven't really rubbed them down yet, so maybe they'll end up looking the same. Let me get some tools and hardware in here and we'll... Something I didn't talk about in the last video is the repeatability of the actual tool post itself. So we assume that when we dropped tool number 2 in, it would always end up at the same position. Like every time you put 2 in, it should be in the same spot. That's not necessarily true. For what I do, this is splitting hairs a bit, but everything adds up when we're looking at the numbers fly around on the DRO. The factory tool holders are good to about 2/10 of an inch. It sort of depends maybe how hard I tighten down on the dovetail, or just how clean or dirty usually everything is. If there's chips and swarf and junk in here, that's going to change the position of where that tool ends up. Anyway, I haven't tried these yet. I've got 2 of my holders there. No sense in putting you through the torture of all 4. And I've got a bit more rigid of an indicator setup. I now have a disc type indicator tip installed on this, which I didn't even know I had. A viewer left a comment in that last video suggesting I look under that plastic back cap, and sure enough, this thing was there. This knurled screw type looking tip. I don't know if that's what it's for, but the threads are the same, and now I've got a bit of a better target for my tools to touch off against. I'm also going to make 2 changes to the DRO. It's currently in diameter mode. I'm going to switch this to radius mode so we have a direct reading of how much the tool is moving. I just hit X, 1/2. SEL is no longer illuminated. SEL, obviously, stands for diameter/radius mode. I'm also going to switch this to 5 digits. So if I switch into metric and switch back, instead of Mori 4, of course, we want Mori 5. I now have an additional digit there. I don't know if that really means anything here. That absolutely drives me nuts while I'm trying to work with the lathe, but hopefully it saves on some of those round off errors. I know last time I said I would do this in metric, but here we are. So I'm going to install what is tool 1 for now. Tighten it the way I usually do. Bring this in past 0 once into the next 0. I'm going to zero out the DRO. Back off. Take the tool out. Reinstall the tool. Come back in past 0. Now I'm going to watch the DRO. All right, it's pretty much right on. Let's do it again. Pass the first 0. As I approach the second 0, I'm going to watch the DRO. There's 0 in the DRO, and we're 1/10 over on the indicator. Again, this is always the same tool. I'm just checking for repeatability when I install it in a tool post. Pass the first 0, approach the second. I'm watching the DRO. 3, 1, 0. And I'm right on. Wow. I'm going to do that one more time. This seems a little too good to be true. 1 to 2/10. For now, I'm going to assume that the tool post is good. at least based on these 3 or 4 tries I just did. I'm going to try this tool library thing again quickly, but yes, a lot of you were correct. When using the tool library with the DRO, you can never touch the top slide or move the tool post. That dial is now off limits. I'm currently struggling internally on whether or not to go to a solid tool post. That means get rid of the entire compound or top slide and replace it with a solid block of metal. Personally, that feels like a lifestyle change I'm not quite ready for yet, but we'll see. Something that does appeal to me though about a solid tool post is the boost in rigidity. Quick, not very exciting story. This lathe, as small as it might look, can actually take a pretty decent depth of cut. Not A-bomb depth of cut, but pretty decent. Here it is about to take on a 1/4 inch cut. 250 thou. That's like 6 millimeters on the radius. Power-wise, the lathe isn't really having a problem, but the guards and all the accessories on the machine are just going bananas. I can't listen to that for more than 3 seconds. Now, that's partially because my machine isn't bolted into the ground, and I don't think all of the panels have all the screws that they should. But that aside, I don't know if I really want to kill my machine this way. The upside to these depth of cuts, however, is the nice chip formation. I don't get the long stringy chips I get if I do a 30 or 40 thou depth of cut. The most I usually push this with carbide is maybe 100 thou. It's 100 thou on the radius. I'm talking depth of cut here. Even that's a little bit noisy, but my feed rate's a little higher. And if I've got a lot of material to remove, I put in earplugs. The other problem with going that aggressive is the tool post currently is only clamped down by this large center bolt. It does have a provision for a locking pin, but my compound does not, and I've never really wanted to drill into it. Early on, when I'd push this machine with heavier cuts, I'd notice my tool post move. And because the pivot is behind the cutting edge, it would tend to roll my tool post into the cut, which is even worse. It results in bad parts. So with time, I've taken to lighter depth of cuts. Again, maybe 30 or 40 thou max at higher feed rates. With a solid tool post and 1 or 2 more screws in the panels of the machine, I may be able to go back to more aggressive cuts. Anyway, maybe we could talk about that some other time, but for now I want to just redo this test with the tool library. Okay, we'll call this tool 1. I'm going to come into that second 0, if that makes sense. I just want to load the indicator a bit. I'm going to 0 out the display. Now we'll switch to tool 2. In X, tool 2 is 35413. I'm going to write that down somewhere. Now if I go in the tool library, tool 2, X 0.35413, enter. Yeah, that looks like 413 to me. I'm just going to 0 out Z. Let's go back to Mori 4. Back into diameter mode. Put tool 1 back in. Let's take a cut and see how it looks. I'm going to take a spring pass just because we're relatively far away from the chuck, I guess. 1.792. X is 1.792. Switch to tool 2. See how close we are to 1792. Oh, look at that. All right, I saw your comments in the last video. Everybody said I bumped the tool off 40 thou instinctually. I didn't go back and see that. I had my doubts, chalked it up to maybe bad editing, but here we go. The DRO is right on. That was my dumb mistake. Last night, I watched the final installment of A-Bomb 79's Best in Show Purge fixture. He also used some cold blue to blacken the hold-down plates, and after seeing his results, I'm starting to feel a little embarrassed. Perhaps I should stop buying the cheapest blue I can find. Nonetheless, I'm really happy with how these tool holders turned out, and it's probably hard for you to tell, but they also taste great too. I'm glad the DRO thing was my bonehead move. I got worried there for a minute. I still haven't used it much, but I'll keep you posted. Quick PSA before we wrap up. I haven't forgotten about the other videos I promised along the way. The gear cutters and mini lathe stuff. I still have every intention of doing those, but I don't want to burn me or anyone else out on just gears. Plus, this is just me screwing around in my garage, so the video schedule is somewhat subject to pure whim. One last thing, I may or may not have promised to break a tap in the beginning of this video. Let me grab one. There you go. Thanks for watching.